Now let's say we have these 10 numbers from 1 to 10. Let's list the numbers that is less than 5. So the numbers less than 5 is 1, 2, 3, and 4. Let's call this set A. Now let's have set B. So let's say the even numbers less than 6. So the even numbers less than 6 are just 2 and 4. Now let's have set C as the list of prime numbers. So 1 is a prime number, 2 is a prime number, 3, 5, and 7. Now let's say we have set D as the numbers from 1 to 4. So that's just simply 1, 2, 3, and 4. So let's say we have another set that contains all the numbers from 1 to 10. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So since we have all the numbers, this is called the universal set, or just denoted by the symbol U. So a universal set contains all the elements being considered in a given situation. So let's say we have set A, just like before. So set A is 1, 2, 3, and 4. Then we have set B, which contains the even numbers, is the 2 and 4. Now, notice that every member of B is also a member of set A. So we say that set A is a subset of B. So written as set A is a subset of B. It is denoted with this symbol. That's a subset. So set A is a subset of B if and only if every element of set A is also an element of B. Now let's say if set A is a proper subset of set B, so a proper subset symbol is just like that, without the dash line on the bottom. So a proper subset if and only if every element of set A is also an element of set B, and that B contains at least one element that is not in set A. So in the previous discussion, I suggest for you to watch it. We studied two ways of representing sets, which is first is the listing the elements, which is the roster method, and second is describing the elements, or the set builder notation. So a set can also be expressed using a diagram called the Venn diagram. So let's have here. So this first diagram shows that every element of set A is in the universal set, which is this. So this big red square is called the universal set. So let's say we have A, like earlier, that we have set A has have 1, 2, 3. Let's say set B has 2, 3. So as you can see, the set B has some elements that is the same on set A. So it will be represented with this diagram. So let's say we have 1 here, then 2, 3. So set A has 1, 2, 3, and set B has 2 and 3. And the universal set is 1, 2, and 3. Okay, let's have another example. Let's say set A has 1, 2, 3. and set E has 4, 5, 6. Now, how are you gonna do that? So, since we don't have any same elements of set A and set B, so the circles will separate. So let's say set A is a separate and set E is also another circle. So we can put 1, let's put another color, put 1, 2, and 3, set A, 4, 5, 6. So this type of Venn diagram that you're gonna use when they don't have any elements that are the same. Now let's identify which of the following is a subset. So as I said earlier, subset if if every element of set A is also an element of set B. So let's say this is set A, this one's set A, and all of these are set B. So let's identify. So is yellow a subset of set A? So by the way, this is the main set, okay? So is this a subset of set A? What do you think? Yes, it is correct. It is a subset since we have Y here and we have Y here. So set B has an element of set A. So how about this? So this is a subset. Subset. Actually, let's use the subset symbol. Subset. So this, we have red. So is this a subset or not a subset of set A? What do you think? So it is not a subset. So why? We have red here. Why it is not a subset? It is not a subset. Red is just an element of the set. So it is an element. If you're wondering why it is an element, since it doesn't have brackets. So if it doesn't have brackets, it doesn't belong on a set. So this is just an element. Now, this red, yellow, green, and blue. So as you can see, this is just the main thing. So it is a subset. So this red, yellow, green, blue, and pink. So it is a subset or not a subset? So it is not a subset since we have something here. So we have P or pink. So it is not a subset. So if it has another element inside it but it doesn't have in the main set, that means it is not a subset. Now this, we have nothing. So is it a subset or not a subset? So what do you think? It is a subset. So keep in mind that every null set or empty set is a subset of any sets. Now, let's have the number of subsets. So how many subsets can we have in this example? 3, 6, and 9. So let's list all the possible subsets. So first, let's go with the single digits. So let's have 3, 6, and 9. Now let's go to the double digits. So 3 and 6, 3 comma 6, and 3 comma 9. That's a 9. That looks like a 4. Now, so we still have 1, which is 6 and 9. So let's add that to the list. 6 and 9. And let's go to the 3 digits: 3, 6, and 9. So keep in mind that a null set is also a subset of any set. So let's add it here. So now let's count. We have 1, 2, 3, 4, 5, 6, 7, and that includes the null sets, which is 8. So we have 8 possible subsets for this example here.